Right, here we're going to look at the addition and subtraction of rational numbers, focusing on rational numbers in decimal form with a friendly number strategy that we'll call over and under. This is based on and builds off of addition and subtraction strategies of over and under that start as early as first grade. In first and second grade, I've made some videos on how we can use that over and under strategy on an open number line, which is going to be the same model that we use here as well, to think about addition and subtraction and to build that reasoning. In 6th and 7th grade, when students start adding and subtracting with rational numbers, a lot of misconceptions and errors start to occur around the, I guess I could say, the lack of reasonableness and the lack of understanding of what these expressions mean and how they are impacted, especially when we cross zero. And so what I mean by that is, if I were to model this first expression, 23.4 minus 78.6. So if I were to start at 23.4 and subtract 78.6, I'm subtracting more than I'm starting with, which means, right, like 0 is somewhere over here. So I'm moving to the other side of 0. The same thing happens in this second expression, negative 152.73 plus 237.5. We end up crossing 0 going the other way, and that leads to a lot of errors, a lot of misconceptions. And if we jump straight to an algorithm, we don't give students the opportunity to build and develop reasoning around that idea. And so a strategy like this, a friendly number over-under strategy, allows students to play with the numbers and develop reasoning along the way to getting those sums and differences and not just getting answers. So we get the answers, but we also develop reasoning about the numbers as we are doing that. So friendly number over under strategy, if this is a new strategy for you, the main idea is that we want to try to get to a friendly number or a series of friendly numbers. Maybe we need multiple steps. With both of these, I'm going to use multiple steps. We get to a friendly number that's over or under, and then we back up in kind of small steps to readjust. And so 23.4 minus 78.6. If this were, let's say, 23.4 minus 73.4, it would be a lot easier for me to think about. That's something that I can do and reason mentally, and so that's actually going to be my first step, is instead of subtracting 78.6, I'm going to subtract 73.4 because I know that is going to land me at negative 50. That first 23.4 that I subtract gets me to 0. I have 50 left, so I'm going to be at negative 50. And that's kind of this idea of let's find and use numbers that are friendly. This is really a strategy I think a lot of adults, I know I use in real life. If I don't want to pull out a calculator, I don't have scratch paper, especially with decimals, walking around the store and thinking, I go in little chunks to make it easier for myself. And so here's how we can teach that to students and model that. So I subtract 73.4, I'm at negative 50, but now I have to start thinking, I didn't subtract the right amount, so I know that my difference isn't negative 50. I'm going to get a little closer to 78.6, and so I'm going to go ahead and subtract 5 more, because that will give me, if I kind of combine these two things together, that will give me 78.4, which gets me a lot closer. And if I subtract 5 more, if I go 5 further to the left of negative 50, that gives me negative 55. The reason that I model this on the number line, and I like working with students modeling this on the number line, is the left to right movement really helps us understand, especially on the left side of 0, whether our absolute values are going up or down. Especially when we get into decimals on the other side of 0. Students, if all they have to work with are the rules, but they have trouble memorizing the rules or they mix the rules up, it's going to lead to errors. And so the open number line allows us to sort of see and visualize and think, which way that we are going. So going 5 more to the left is negative 55. And so now I've subtracted 78.4, but still not quite right. I'm supposed to subtract 78.2. So now I just have to think, how much more do I need to get from 78.4 to 78.6? And I know if I subtract 0.2 more, that's gonna put me at my difference. That's the number that I need. And 0.2 further to the left of negative 55 is just negative 55.2. So 73.4 minus 78.6 is negative 55.2. Now, certainly I could have lined those decimals up and subtracted and understand my rules around positive minus negatives, negatives minus positive, adding. I know those rules. I can apply those rules, and I could have gotten the difference a little faster. However, if I forgot the rule or mixed up the rule, I would have gotten the wrong answer. But more importantly, this allows me to develop some reasoning along the way. And this is something that students will be slow at first, and that's okay. We go slow to go fast. Eventually, they'll be able to make bigger jumps, more sophisticated jumps, and maybe even do some of these steps in their head as well. So let's look at an addition example as well, but I also wanted this to be one where we have some decimals and we're crossing zero, because that's where a lot of the complexity and the errors and misconceptions might come in. So negative 152.73 plus 237.5. So I'm going to start here, and I know that I want to add 237.5. However, I think that I could do negative 152.73 plus 252.73. I can do that in my head. That's a much easier problem that's relatively close. So instead, I'm going to add 252, or I'm sorry, 252.73. And again, I'm adding this because I know I can do this and get to something a lot more friendly. That first 152.73 that I add is just going to get me to 0, and then I have 100 left over. So here we are at positive 100 after we've added 252.73. But I added too much. So now I have to start making my adjustments, and depending on the level of student and where those jumps are, what jumps they can make, this is more or less efficient. But efficiency right now isn't the goal. Of course, we want the right answer, we want to be accurate, but we also want to build reasoning. And so the first jump that I'm going to make, I'm going to go back 20. I'm going to erase my 0 here because that proportionality wasn't exactly looking accurate. I'm going to go back 20, which will put me at 80, because once I go back 20, if I think about now how far I jumped ahead, I jumped 252.73. If I back up 20, that was 232.73. So that's getting me closer. Now, still not there. I still have to make some more fine adjustments. So I was supposed to add 237.5. So now I want to get to 237, which means I need to add 5 more, which now we're at 85. So now I have added 152.73 plus 237.73. And if I were modeling this with students or doing this on my own, I wouldn't have rewritten that. I'm just rewriting it for clarity right now. So I just have to think. I've added 237.73, but I was supposed to add 237.5. So did I add too much or not enough? This is that over-under idea. And in this case, I added too much. 0.73 is more than 0.5. I added 0.23 too much. And so I need to back up 0.23. I'm going to back up 0.23. This is where I think one of the most underrated fluencies comes into play. I think, especially by 6th and 7th grade, if students know their pairs to 100 really, really well, it pays off in a lot of different ways. And this is one of those ways. I'm very fluent with my pairs to 100. When I see 23, I sort of immediately think 77. I know 23 and 77 are pairs to 100, and that helps because since I'm backing up 0.23 from 85, I know this is going to be 84.77. So negative 152.73 plus 237.5 or and a half is 84.77, and that is the friendly number over under strategy for addition and subtraction with rational numbers.